Hi guys, welcome back to my channel. Today I'm going to take you through product rule. In the last video, I explained the three approaches you could use for different functions in differentiation. I said we have product rule, that is when you have your U multiplied by V. So that is when the difference when the relationship between the two functions U and V are in terms of product. So then I have quotient rule, that is when your relationship is in terms of fraction. Then likewise the composite function, which you are going to use chain rule. You don't need to stress yourself. Before you can do any of this problem, ask yourself first, do you have the function in terms of fraction? If you have the function in terms of fraction, then automatically you are going to use what? Your quotient rule. But if you don't have your function in form of fraction, then you have product, you have the option of using product or what? Or composite function. But you can only use product rule when you have two individual functions, or when you have more than a functions, and the functions, the relationship between these functions is multiplication. For example, if I have y is equal to f of x multiplied by g of x multiplied by h of x. You know this is a function on its own, this is a function on its own, and this is another function. Then in this particular case, you are going to use what? Product rule. And don't forget what I wrote the other time, that is when you have y is equal to uv, then your dy dx will be what? You differentiate the first one, the u dx, you leave the second as it is, plus differentiating the second, leaving this second, leaving the first as it is. It is not difficult. When you have your y is equal to gh, then if both are function of x, what you are going to do is differentiate the first, leave the second as it is, plus differentiating the second, leaving the first as it is. This clue is very important, especially when you have more than two functions. For example, if you have 5 functions and you want to differentiate, you don't need to stress yourself. You differentiate the first function, leave the remaining function as they are, plus differentiating the second function, leaving the rest of the function as they are, plus differentiating the third, leaving the rest, so and so on and so forth. Let me give you an example to back it up. Example, differentiate the following. 1, e raised power y is equal to e raised power s cos x. Number 2, x square plus 3 tan x with respect to x. It is very simple. Look up solution. If you look at this very well, ask yourself, number 1, can you use quotient rule? That is impossible. Why? Because your function is not in terms of h, in terms of fraction. Okay, now ask yourself, are you going to use product rule or function of a function? So you can see this function is in terms of a product because this is a function, this is another function. We can split the function into two. You understand now? So then what you are going to do is to make the first function to be u and the second function to be h, to be v. So then you now differentiate it. You differentiate them, sorry. Okay, now what is your du dx? That is e raised power s. Don't forget, from your standard integral, derivative of e raised power is also e raised power s. What is the v ds? From standard integral, it is minus sin x. And with the formula I wrote for you, that is when you have your function in terms of products like this, then your dy dx is what? Don't forget, differentiating the first, leaving the second as it is, v du ds plus u dv ds, which is same thing as leaving the second, differentiating the first, plus leaving the first, differentiating the second. So you can do it like that, or you just substitute directly. So what is my v? Your v is cos x, the u ds is what? E raised power x, plus what is your u? E raised power x, The VDS is what? Minus sin x. So you can see that e raised power x is common. Then I have cos x minus sin x. It's very simple, isn't it? Okay, now let us do the second one. I have y is equal to x square plus 3 tan x. We know already that we are going to use product rule because automatically this is not trivially this is not a quotient function, so you are not going to apply quotient rule, and you have this function in terms of product in the sense that this is a function, this is another function. Okay, now don't forget the approach. If you want to do it without writing this formula, perhaps we are doing a multiple choice. It is very simple. What you are going to do is differentiating the first function, that will give me 2x, leaving the second as it is, tan x, plus differentiating the second, that will give me x square s, leaving the first as it is, that's x square plus 3. It is very simple, but if you want to solve it using the approach I did the other time, then your u will be what? I used the other time, your u will be x square plus 3, your v will be tan x, then you differentiate u, derivative of u with respect to x will give me what? 2x. Then you differentiate this v with respect to x2, that will give you x square x. Then you now substitute into your formula v du dx plus u dv dx. You don't need to memorize the formula. It's the same thing as differentiating the first, leave the second as it is, plus differentiating the second, leaving the first as it is, the main function. Then your y will now be tan x multiplied by du dx, that's 2x, plus u x square plus 3, the v dx will give me x square x. Then I'm going to have, don't say tan x multiplied by 2x, it is not tan 2x squared though, because this is a function on its own, you cannot break it. This is another function, and this will give me tan 2x plus x square plus 3 x square x. You know, it is the same thing as what we did the other time. You understand now? So it's the same thing as the result, the same thing as this. So this is how you are going to use product rule. That is, you make the first function u, make the second function v, and you differentiate both of them, and you put them into the formula v du ds plus u dv ds. So which is the same thing as differentiating the first, leaving the second as it is, plus differentiating the second, leaving the first as it is. Even if you have 100 function, don't forget, differentiate first, leave the rest of 99 as they are, plus differentiating the second, leaving the rest of 99 functions as they are, and so on like that. So if you enjoyed this video, please don't forget to subscribe. If you've not done so before, don't forget to like and share my channel with your friends too. So I will meet you in the next video. Thank you.